You ever wonder what a digital photo really is? Let's break down the secret language of these files.
Okay, so we see a beautiful bird, right? But to a computer, it's a totally different story.
If you zoom way in, you'll see it's just a bunch of colored squares. We call them pixels.
And what are those pixels made of? Numbers. Just a huge grid of numbers for color and brightness.
So yeah, your files are basically just giant spreadsheets of numbers, and they come in different dimensions.
A 1D signal is just one row of numbers changing over time, kind of like the audio you're hearing now.
A 2D signal, that's a grid of numbers, a matrix, and that's how we get a still image.
Now, stack those grids, and you've got a 3D signal. Think of an MRI scan or a color photo. And a 4D signal? That's a sequence of those 3D stacks over time. And boom, you've got video. What's really cool is you can actually play with this digital DNA yourself using a tool like MATLAB. But here's the problem. These arrays are huge. So how on earth do we store all that data? Well, we use some pretty clever tricks. The big one is compression, which just cuts out repetitive info. It comes in two flavors: lossless, which keeps everything, and lossy, which smartly tosses what you'll never miss. We also use color spaces that copy our own eyesight. This lets us squish color data more than brightness. All this leads to different formats, each trading quality for size. You gotta choose the right one. But what if? What if we didn't have to use a grid of pixels to make an image at all? Instead of pixels, vector graphics use math. This means they scale up forever and stay perfectly sharp. The big one here is SVG. It's less like a picture and more like a recipe to draw a picture. And this whole rules, not grids idea, that's the blueprint for how we build stuff in 3D. So 3D models have their own formats, for 3D printing, AR/VR, or even complex science projects. This creates this awesome modern pipeline. You capture the real world, model it, then create something totally new. From just one digital file, you can make a real physical object, like a prototype or a medical implant. Or you can use that same file to build an entire virtual world you can actually step inside. So there you have it. We went from a simple grid of numbers all the way to physical reality. Our entire world is being translated into data. The only question left is, what will you build with it?